Hello everyone, in this video we are going to solve the problem called next greatest element, and let's read the problem. So we are given a two array nums1 and nums2, where nums1 is a subset of nums2, which means basically nums1, all the elements in nums1 are present in nums2. So for example, in this example 4, 1, 2 is present in nums2. So the nums2, think of nums2 as a parent, and this is some of the elements which exist in the parent array. So they want us to find all the next greatest element for each of the numbers in nums1. So for example, for nums1, 4 exists at nums2, right? So the next greatest element to this 2 is not next greatest, so if it doesn't exist, you just put -1. Alright, let's go to 1 and we'll look to its parent array. The next greatest element would be 3, right? Because it's the next greatest one. So that's why we have 3 here. And for 2, the next greatest element, you look back here, and 2 doesn't have any right side, so we put -1. In this example, we have 2, and for 2 here the next greatest element is 3, right? And for 4 it's -1. There's also a case where this is a subset where we have let's say put a set here, so we're just gonna put like 5, let's say 11, 4, 5, 6, and maybe 20. So and then the subset is 11 and 4 and 20. So what should we return? So the next greatest element for 11 should be, it's not 4, right? It's not 5. The next greatest element is 20. So it should be 20 for 11, and for 4 it should be 5. So that's why we have 5 here, and for 20 we have nothing here, so it's -1. So now as you see that if there was, like, let's say we had 25, then this would be not -1 but 25. So the next greatest element you get, right? Like for 11, the next greatest 4 didn't work, so next 20, it won't be 25 because we are looking for the first one we see, which is greater than this number, is considered the next greatest element. So how would we approach and how would we solve this? So if you have noticed, if we have let's say 11 for let's say 3, so it's decreasing. There's no next greatest element for 11 because 4 is not, and there's no next greatest element for 4 yet, and for 3, once we go to 3, so it's in a descending order. 11, 4, and 3 is in a descending order, and then suddenly we find a number that's greater than 3, 4, and 11. So 20 is the next element for 3, for 4, and 11. So if you've noticed, we went all the way down, and then we find a number that's greater than the top one, the 3. So before solving this problem, you have to think, like, what kind of data structure I should use. Like, if you notice, you're not touching 11 yet. So if you don't see the number that's greater than the left than 11, you go to the right? So, and you say, like, hey, I come back to you. So once you go to 4, it's not greater than 11, and then you want to find next greatest element for 4, and then you go to the right again. So you kind of like putting them somewhere. So what do you think we could use? Like, first putting 4 on top of 11, putting 3 on top of 4 until you see 20, and then you get rid of 3. So I should remind you of a data structure called a stack. So what is the logic here? Alright, so the logic here is, so basically we have to find next greatest element for each of these numbers in a set, in a nums2, right? So in order to do that, we first gonna go iterate through each element in this array, in the second one. So, and we also have a stack. So let's see, this is the top of the stack, this is like the bottom. Now at 11, so we first put 11 in our stack because we have to compare the right side to the left. So we start traversing from the index 1, and then yeah. So let's say we already have 11. We start with we put the first index element in the stack, so our stack is not empty. So once we get there, so as I said, we traverse from 1, right? So once I start traversing from 1, I'll compare 4 and 11. So I would compare 4 and 11. So 4 is not greater than 11. So if it's not great, then we haven't found the next greatest element for 11 yet, right? And we haven't found next greatest element for 4 yet neither, because we have to check it with 3. That's why since 11 is not greater than since 4 is not greater than 11, so we put 4 in here too. So remember, I said you keep going until you find a number that's greater than the previous one. So now we are at 3, right? We started at 4, traversing at 4, and now we are at 3. So, and now we compare 3 to 4. So how am I comparing it? I'm just comparing it to the top of the stack, and the top of the stack is 4. That's why we started from 1, not from 0, because our stack already had 11 here. So I'm just comparing 4. I just compared 4 to the top of stack, which had 11 in it. Since it wasn't 4 wasn't greater than 11, then I put 4 in here. Now I'm at 3. I'm gonna compare 3 to 4. Now 3 is not greater than 4, so since not greater than 4, we are gonna put it here. So all of these elements don't have a next greatest element yet. So the next greatest element should be any large number that's on the right. The first large number that's on the right. So okay, now we go to 20. Now 20, once we see a number, and so we compare it with 3, right? So currently 20 is greater than 3, so that means that 20 is the next largest element for 3. So what do we do in this case? So so once we see the number that's greater than 3, we pop the 3. Now once we pop the 3, we can create like a mapper dictionary, where like a hash map, where we have the key and the value. So when we pop it, we store it in the dictionary, and the value would be its next greatest element, which is 20, right? Awesome. So that's for our reference, so we can use it at the end. So I'm storing just the next greatest element for each element in the array, so I can use it later. Now I popped the 3. Now we have 20, right? I popped the 3, and I stored it in here with its next greatest element. Now if you notice here, I'm doing a while loop. And I take the 4, I pop the 4 now. Now I'm going to compare 4 and 20. Now 20 is greater than 4, so that means 20 is the next greatest element for 4. So I'll do the same thing and store 4 in the dictionary, and then put its next greatest element. And now the next thing to do, I popped 4. Now next thing I pop, and I compare 20 with 11. You only pop it if it's greater than 11. If it's not great, so we'll take a look at that. So now 20 is greater than 11. Then I'm gonna pop the 11 too and store it in here. But now what are we going to do with 20? We're not just gonna like get rid of 20, right? We want to know what's the next greatest element for 20. So in order to do that, after after all that, we also gonna put 20. We just append 20 in the stack. And once we do that, we exit the while loop and we end up in the for loop again, and then we end up at 25. So now we are at 25, and then we compare 25 with 20. So 25 is greater than 20, so we pop the 20 and then store, we should just say 20. Its next greatest element is 25. So the same thing, we have to put 25 in the stack. So at the end, there will always be an element in the stack because there's not anything on the right. So our stack will never be empty. So whatever in there, its next greatest element is -1. So at the end, we can do another for loop in a stack, for key in stack. So and then we just say if our dictionary is called mapper, we can just store that key and then equal to -1. So that would be our 25 would have a value of -1 because this doesn't have a next greatest element, right? So yeah, that's it. And at the end, so the reason we stored our results in the dictionary, so what we're gonna do now, we're gonna go through each element in a subset. So for 11, and on our response array, it's basically for each element in 11, and we store that value in our response array. So so for key, so which is 11, and then okay, so it would be like something like this for key in. So if this dictionary is called a mapper, for key in mapper, the value would be mapper key. So for key, oh no, not for key in mapper, for key in the first array, so nums1, so that would be 11, and mapper 11 would give us 20, so the first one would be 20. The second next greatest element for 4 would be mapper 4 would give us 22, so this is 20, and mapper key, which is 20, give us 25. So this is our results. So we just return this result at the end. Okay, so I can show you the code. So I got it wrong the first time because I didn't use a stack. I thought I can solve it with just looping through an array, but it didn't work. So here's my first solution, and here I'm just checking if it's not empty, and then I have a mapper, and as I said, I'm starting my stack with the first element. I put it here, and then I'm going through each element in nums2, so I'm starting from 1, and the condition of the while loop is while stack is not empty and the current number is greater than the top of the stack. It's the same thing. It's an example. If you think of an example I went through at the beginning of the video, and then I'm just putting it in the mapper, and then appending after doing the while loop. Once I pop everything, finally I put the number in a stack, and then at the end, since the stack will not be empty, the leftover should have the next closest element of -1, and finally I return all the results for the keys that are present in the nums1 array. So that's it for this that's it for this problem. Okay, so I can show you how it works. It's pretty easy problem to solve. You just know to stack. Yeah, so that's it, and thank you guys for watching the video, and I'll see you next time.